Hey guys, so today we're gonna do 3.2. We're gonna do that chain rule. So remember all the insides, right? Derivative, derivative, derivative. But we're gonna do it this time with exponentials and logs, okay? So these are rules that we are gonna memorize. So if you're starting note cards already, these will be ones to do on there. When we hopefully get back after Thanksgiving break. I already ordered a bunch of note cards that we can start making our study cards, okay? So for this, since the derivative of e to the x is e to the x, we have to remember the chain rule. So in other words, if this was something other than x, we would have e to the u and then times the derivative of that u or whatever is in that exponent, okay? And then we know that ln of x is 1 over x. So ln of u, so in other words, if this was something other than x, we would multiply it by the derivative of that inside, okay? So they're actually also doing some other things with ln, oh no, a to the x. So this is your new one. This is like 2 to the x or 3 to the x. So it's that base. They're proving it to you by actually taking the derivative of these things, okay? So right here it says inverse properties. So what they did was, hey, let's do e to the ln because of course they cancel, correct? All right, so putting e and ln right here doesn't change the function, it's just helping us solve, okay? Now, of course, knowing that, another property that we need to use is the exponent goes in front as the coefficient, okay? So that's what they did for the next step right here, is they have e to the x ln of a. Now, just to tell you, ln of a is just a number because a is any number, ln of any number is a number, right? So think of this as a number x. So when we do the derivative, and we have to think of the chain rule, right? We get e to the x ln a, and then times the derivative of that exponent there. Well, number x, the derivative of a number x would just be the number, which in this case is ln a. Now, they're going to reverse what we just did with the same log property. So what we're going to do is put that x back as the exponent. Sorry, my pen's not doing well. ln a to the x times ln a. Then what happens here? Our e and ln cancel. So what are we left with? We're left with a to the x times ln of a. So that is a new derivative rule, okay? So I would do it in terms of the chain rule here. So let's look at a to the u. A to the u, the derivative would be a to the u times the derivative of that exponent times ln a, okay? So this is, let me get a highlighter. These are some weird ones. So I think you have one of these on your derivative packet too, towards the end. So that is a property we need to start memorizing. Next, we're going to do the derivative of log base a. So remember, a is a constant of x. Now, of course, if it's u, we're going to do times the derivative of u. Okay, but this is just proving it right here. So we know we can change log base a of x equals ln x over ln a. That is the change base formula. If we didn't have our calculator, that's what we would do. Okay, so what does that mean? Don't forget that ln of a is just a number. And then we have ln of x, Well, the derivative of ln of x is 1 over x. And remember, since this is just a number, it stays out front. It's that scalar multiplication, okay? So in other words, we can write log base a of x will always be 1 over x times ln a, okay? Now, we're going to do some chain rules here, and of course, I'm going to put this down so you guys remember those rules, okay? Let's do some chain rules, just normal practice stuff, okay? Excuse me. All right. F of x equals e to the x squared plus 3x. Remember what that is, chain rule, right? Well, we take the derivative of the e, which of course is itself. So I'm just going to put e to the x squared plus 3x. And then we have to multiply by the derivative of that exponent. The derivative of that exponent is 2x plus 3. And we're done. Okay? Same thing here. Okay? I'm actually not going to, well, it's using the u prime, but again, I'm going to do this chain rule. So the derivative of ln is 1 over what we have. So what we have is 3x. Now we have to multiply it by the derivative of that inside. Well, the derivative of that inside is 3, and we're done. If you need to simplify that more, the 3's cancel, and we end up with 1 over x. Okay. This one has us use our, this one's actually doing it a different way, because what they're doing is they're separating the ln. So remember, multiplication is addition. So now if we took the derivative this way, we would see that ln of 3, well, that's just a number. The derivative of any number is 0. And the derivative of ln x is 1 over x. So that's where those are the same. So those are just 2 ways to do it. I try to just use a chain rule every time, but that's going to be up to you guys. I'm going to change my writing utensil because it's getting annoying. Okay, so in other words, with this one, we can't separate it like we did this one. We have to do it by doing the chain rule. Okay, so the derivative of the outside, well, the derivative of ln is 1 over what we have, which is t squared plus t, times the derivative of that inside, which happens to be 2t plus 1. And we're done. Okay, let's go on to the next page, see what else they got for us. All right. Okay, h of x equals x times ln of x. Well, okay, I just said times, so that must be the product rule. Product rule says the first function times the derivative of the second. Well, the derivative of ln is 1 over x plus the second function, which is ln x, times the derivative of the first, which is 1. So if we were to reduce this or simplify it, x over x is 1, and then plus ln x, and we're done. All right, this one. Let's rearrange this so we don't have to think about using the quotient rule, and this is t. So we would get e to the negative 3 t negative to the negative 1. Okay. All right, so chain rule, right? So derivative equals, well, the derivative of e is just itself, so e to the -3, t to the -1, times the derivative of that exponent, well, that's the power rule, so bring -1 down. -1 times -3 is 3, t to the -2, and we're done. All right, I'm going to rearrange this again. So this is 3 to the v to the 1/2. Okay, so this is one of our rules from before, right? So many of you might say, wait a second, I don't have that memorized yet. So go back to the other page. Remember, so a to the u, so we keep a to the u, we do the derivative of the exponent, and then times ln of a. So that means a to the u, so we're going to keep a to the u, which is 3 to the v to the 1/2. Now remember, it's times the derivative of that exponent, which is 1/2 v to the -1/2, times ln of a, which in our case is 3. All right, I'm gonna, next question here, it's just having you do some analyzation of the, dude. Hopefully you guys are hearing me. I don't know why I did that. All right, sorry guys. Computer's being funny right now. Okay, let me get back here, and then I'm gonna have to check that all of this recording correctly. Okay, so it wants us to graph ln absolute value of x, okay? So I'm going to graph that on my graphing calculator right now so you guys can see it. And this should make sense because remember what absolute value on the inside does, it makes us reflect to the other side. Now, it's making us analyze the left and the right side of the graph because when we take the derivative, what you find is that the derivative, and I'm going to do this in red so you guys can see it, the derivative actually gives us 1/x, which is the same as just ln of x. So the idea of what's happening here is it's saying that no matter what, if you have an absolute value, that it really doesn't matter, you can ignore it. Now, why is it there and why do we have to point that out? Well, going backwards is a different case that we have to think of. So if you see the absolute value, which we're going to do one down here, we don't have to really consider it. We can ignore just taking that derivative, okay? So example 9 here, ln, so let's take that derivative, right? So the derivative equals, well, the derivative of ln is 1 over what we have, which is 5 minus 2y cubed, times the derivative of the inside. Derivative of 5 is 0, and then the derivative of -2y cubed would be -6y squared, and we're done. Okay, no worries about the absolute value. All right, when possible, expand the logarithm. So as you can see, guys, this is a total mess. I mean, the last thing we want to do is 1 over all of that times the derivative of that, because we have a quotient rule within a product rule and we have a chain rule. It's all messy, right? It looks like a big mess. So let's rewrite it by expanding first and then take the derivative. So if you remember, anything on top is the addition, and on the bottom is the subtraction. Oop, forgot the ln. ln of x squared plus 1. Okay, now we have some chain rules to think about. I'm actually going to rewrite this even more. I'm going to rewrite this little piece right here, because here we have ln x, that's great, plus, now remember, square root is to the 1/2, and when we have an exponent there, we can bring it out front to be that coefficient. And that makes it a little bit nicer when we take this derivative here. Okay, so let's take our derivative then. Y prime. Well, derivative of ln x is 1/x plus, keep that coefficient out front, that scalar multiplication, right? That just stays. Derivative of ln is 1/, what we have, which is 2x plus 1, times the derivative of the inside, which is 2. Got to be careful with those chain rules, right? Minus ln, the derivative of ln is 1/, what we have, times the derivative of that inside, which would be 2x. Okay, we could simplify this more because the 1/2 and the 2 cancel, but that's all. We don't have to go any further unless we were told so. Okay. All right, last one. Again, even though you would like to use your calculator on this, we're going to do it without a calculator. We're going to practice those the new rules. So log base, if you remember, or if you need to look back at the other page. Remember, ln base a of u is the derivative of u all over u times ln of a. Okay, so let's find that derivative and plug in. So y prime, I'm going to do the derivative of the outside first. So we've got u, which is this x squared plus 1, times ln of a, which in this case is 2. So 1 all over that. And then we need to multiply it by the derivative of the inside, that u prime. So 2x. And we're done there. But we need to say the derivative at 2, right? So we're going to plug in y prime of 2 equals 2 times 2, right here is 4 all over 2 squared is 4 plus 1 is 5, so we get 5 ln 2. Now, just in case this is multiple choice, I'm going to go further and bring that, remember the coefficient in front of the ln is actually an exponent. So we would have 4 over ln, and 2 to the 5th is 32. So just in case we have multiple choice and it wasn't a calculator, we would have to rearrange that. Okay, try those out. Take your time, and then maybe you can do more on your derivative packet.